So it was nice of us in these last several story problems that when the lovely people that wrote these problems, myself and Steve, wrote these up, we did it in such a way that it kind of picked it apart for you into multiple pieces, A, B, C, and so on. But often we're not given that walk through in a problem, and you got to figure it all yourself. So here's the process that you can use to get through it. You read the problem, then you reread the problem, right? And honestly, it helps, as you've been seeing, underlining the important numbers, maybe highlighting with different colors the different pieces that go together, that kind of thing, or using different colored pens. You can draw diagrams and so on. Then you need to write a model. Right? We did that all back here. We would find the equation and stuff. But if I don't ask you for it, you still have to find it. Okay? In order to answer any problems. And then you substitute and solve, which we were doing right down here, right? We would put the 31 in stuff, right? So what I'm saying is if all I asked you for was this part down here for part C, you need to be able to go through parts A and B on your own without being asked in order to find part C, is basically what we're saying. All right, so let's do it. As you might imagine, this process is a guideline, and of course, it won't work perfectly for every problem. You've got to be able to handle different kinds of things being thrown at you. So let's look here. The number of girls in millions participating in high school sports has increased approximately linearly from 1.9 million girls in 1990 to 3.0 million girls in 2004. Based on this data, predict in which year the 4.5 million girls will participate. Right, so there's the problem. Now notice they didn't say find the slope, find the intercept, explain your variables, none of that. They just said when will be 4.5 million girls. But to do that correctly in an algebra and stats context, you've got to find all these pieces even without being asked. You've got to define your variables. So T was the years since 1990. Notice that's our independent. Again, years independent like X. Then Y was our dependent, which is the number of girls, right, in high school sports. Then we have to make some ordered pairs out of what they gave us. And I did it in colors. This is red right here. 1.9 million girls in 1990. Well, that's 0, 1.9, right? So T, N is how our points are going to go. 0 was 1990. That's our starter year. Now notice that's the n-intercept they're giving you, which means automatically B is equal to 1.9. You've already got part of your equation pre-given to you in the problem. Right here. Then they gave us this purple one right here, 3.0 million girls in 2004. 2004 is 14 years away from 1990, right? So you can subtract 2004, take away 1990, you'll get 14. So 14, 3. There's our other point. Now we know the n-intercept is 1.9. All we got to do is find the slope. So you take n2 minus n1, that's like your y, right? y2 minus y1. And don't forget, this is, what was this? Number of girls. I think it was in millions. So number in millions over year. It always pays to kind of keep track of your units. You never know if you're going to have to use them somewhere. So it was, 3 take away 1.9. Those are our two n values, over 14 take away 0, which was 1.1 over 14, which came to 0.08 over 1. Notice it's increasing because this is a positive number. It's not a very big number, but it's positive. Therefore, our line is increasing because our slope is positive. And that means our equation, the model, is n equals 0.08t plus 1.9. And again, the 1.9 was just because they gave it to us in the problem. They told us that at year 0 it was 1.9. They didn't say year 0, they said 1990, but then they later told us. Actually, they didn't tell us. But let's make it that way. I mean, why not make it since 1990? It makes our life a whole lot easier. Right? So they didn't write it anywhere for us, but nothing's stopping us from using it. And I say let's use it. Let's make it since 1990. And that makes this thing automatically our n-intercept, and things are grand. All right, so then they want to know when it will be 4.5 million girls, right? So that's what they're actually asking. And notice they say predict in which year. See that part? You're looking for time. Which year will it be 4.5 million girls? So you have to take the 4.5 and substitute it in for n and solve that equation for t. So you'll have to subtract 1.9 from both sides and over here. All right, and that gets you, let's see, 2.6 equals 0.0, oops, equals, there we go, 0.08t. Then you got to divide both sides by 0.08. And you do it to the left, do it to the right, down here. And you're going to get that t is about, let's see, 20 or 32.5. Oops. And again, I just used a calculator to find that. 2.6 over 0.08. You get 32.5. Now, if you take your starter year, which was 1990 plus 32.5, you're going to get 2022.5. 2022. So in 2000, there's our answer right there. Kind of in the middle of the year 2022. And that's what we'll say down here. So in 2022, there were an estimated 3.5 million girls participating in high school sports. Oh, 4.5. 4.5 million girls participating in high school sports. So what they were really looking for was honestly this whole year thing. What year was it? Right, 2002. But you had to do all these intermediate steps to get there, right? You have to find your variables. You have to, figure out your points that you were given. Pick a smart year. Pick 1990 to be your starter year, even though they didn't give you a starter year. Make it up. Make it one of the years you've got, and that'll make things simpler for you for your n-intercept. Make it the lower of the 2 years you've got. So pick 1990, and so on, right? Then you've got to find your slope. Then you can use, if you're wise and picked that to be your starter year, then you can just put that number right there in for the y-intercept, and then you can solve, right? Substitute and solve. And what they were really looking for was this whole 2022. Sorry, 22, not 2002. 2022. All right, now let's do it again. The percentage of Major League Baseball players who are African American declined approximately linearly from 17% in 1997 to only 8.4% in 2006. Based on this data, predict when 1% of the players will be African American. And I already highlighted this in red right here. 1997, 17%, and then 8.4% is 2006 in purple. Now, I had to make my variables. They didn't ask me to, but I'm going to have to if I want, to get this question correct. So I made time, which was years since 1997. And I just chose 1997 to make it easier. Matter of fact, I can put that back on the other one. I just chose 1990 to make it easier. Didn't have to be, right? And then N was further, right? So down here on this one, we're just choosing 1997 because they didn't give us a starter year. So let's pick one of the ones we've got. Let's pick the lower one of the ones we got. And then P was the percent of players that were African American. Actually, it's the percent of baseball players who are African American, to be specific. So it's a percentage of MLB, Major League Baseball players. Major League Baseball, MLB, who are African American. So that means our points are going to be T comma P. T is the independent variable. P is the dependent variable. So we've got 0 comma 17, right? Because 0 was our starter year because we made it that way. So 0, 17, that means the n-intercept is given, which means automatically B is equal to 17. 17. Nice, huh? That's why we did it. That's why we chose this, was so that this would work out. B was equal to 17. All right, so then the other year was 9 comma 8.4. Where did I get the 9 from? Well, you just subtract. 2006, take away 1997, you get 9. So 8.4. And then you got to find your equation. So it's P equals MT plus B. You need P2 minus P1. And let's make a note right now. This was percent MLB that are, I'm just going to put A-A, African American, over year. Okay? So just to keep in mind for myself later on. So it's the percent that are African American, percent of the MLB players that are African American over the year. Then I took 8.4, that purple 8.4, minus 17, that red 17, over 9, take away 0. Okay? And that came to negative 8.6 over 9, which comes to about negative 0.95555 over 1, or negative 0.95. So then our equation is P equals negative 0.95555 T plus 17, because 17 was our B value, right? All right, then they want to know when it will be 1%. So you take, notice that word when. They're looking for time, t. So you're going to take the 1%, that's a percentage. You're going to put it in for p, for percent, and then you're going to solve it for t. You're going to start by subtracting 17 from both sides. Actually, let me just type this up. I'll be right back. All right, so here we are. I subtracted 17. That got me negative 16 over here because 1 take away 17 is negative 16 equals negative 0.95t. Then you got to divide by negative 0.95 to get it on its own, get t on its own. So I need to take negative 16 over negative 0.95. I'm going to get t is about 16.744 or so. Right? Okay, so then what is that? That's time, t, right? So what year are we talking about? So you take your starter year, which was 1997, and you add to it 16.7, and you get about 13.74. So about 2013, right? You could say in 2013, I guess is what we could say, during 2013. There we go. So during 2013 is when there should be only 1% of, and that's what I will write up down here. Hold on. There we go. During 2013, only about 1% of the Major League Baseball players are expected to be African American, according to our model. So in the middle of the year 2013, or you could say by 2014, because by that time it'll be all done if you round up. But you could just say during 2013 or in the middle of 2013 or something like that. All right, and again, it didn't ask us for all this intermediate work. All it asked us was for this final answer, 2013. But the final answer alone is not enough. You've got to do all this work and set up all these variables in order to find that. All right, we are all done with that section. I hope you've enjoyed all your Unit 6 lecture notes because we are done. See you on the flip side.